So chiller, what is chiller? If you are new to chiller system or air conditioning, you must heard of the word chiller, right? So what is a chiller? So chiller basically is a big air conditioner, right? But the working principle is slightly different. And chiller, in fact, is used in many large building. When we talk about commercial large building like hotel, mall, office tower, and even maybe your office now, if you are staying in a big office, right? Maybe you are using chiller, a form of chiller. Either is using water or using the air cool, right? So let's talk about what is a chiller. So a chiller, right? Why chiller? What is a chiller, right? Because what is different, between a chiller and our house air conditioner? You see, house air conditioner they use air to cool things. A chiller is different. Chiller will produce cold water. Then the cold water will be sent to those air conditioner that we call air handling unit and fan coil unit. Then they will produce the cold air. So house air conditioner we use refrigerant. We directly send refrigerant inside this small air conditioner we mount on the wall or on the ceiling, right? For chiller system is different. We will send cold water to this type of small air conditioner and let them do the cooling work. So that's the job of a chiller, is to produce a cold water. So the temperature is about 5 to 7 degrees Celsius, right? So just like any air conditioner, the chiller also works using the refrigeration cycle. So what's different is here. So the compressor will send the refrigerant to the condenser, right? So at the condenser, we normal house air conditioner will use air to cool it. Then for a chiller system, we also use air to cool. And this is one of the type of the chiller. Then we call it the air cool chiller. At the same time, right, we also can use water to cool the refrigerant. The heat rejection process, we can use water. So this is what we know as water cool chiller. And after that, then we go to expansion valve. We go to the evaporator. It's the same thing. At the evaporator, again, we are not using air. We are using water. So we are producing chill water. Now we use water for the heat absorption process. So this is how chiller is different from this normal air conditioner. So a water cool chiller, the first component is the evaporator. So the evaporator is just a shell and tube heat exchanger, right? And it is the one that is producing the chill water. The second component will be the compressor, so the major one. And for chiller, right, for water cool chiller, right, we have two major type of compressor, which is the screw and the centrifugal. The big capacity one, if you want big capacity, usually we will use a centrifugal compressor. Then it will become what we call centrifugal chiller. Now, if you heard of centrifugal chiller, it's actually the compressor, the centrifugal compressor, and also the screw chiller, screw compressor. So if your capacity is not that big, medium capacity, then we'll use a screw compressor. And then we have a expansion valve, obviously for the expansion process somewhere there. And also the last component is the condenser. So this is the one that we call water cool or air cooler. It's also used a shell and tube heat exchanger for most cases. So air cool chiller also about the same, also about different. The difference is at the condenser side. The condenser for the air cool chiller is just like our normal house air conditioner. We have the fan, we have the thin tube heat exchanger. Then we use outdoor air to cool the refrigerant, right? And for compressor, we also have the screw type. If the because air cool chiller is like lower capacity than water cool chiller. Water cool chiller can go very high. Air cool chiller is smaller, and the big size air cool chiller will use screw compressor. The small size air cool chiller will use scroll. Many small scroll compressor made out of air cool chiller. And expansion valve, we have expansion valve. Then also we have evaporator. Evaporator, same thing, produce chill water. So a chiller actually have a lot of different name one. The first is air cool chiller and water cool chiller. After that, then we can also name the chiller by their compressor. Some people they say okay, screw compressor and also centrifugal compressor. Then become screw chiller, centrifugal chiller. Then after that, if you go deeper, is we have the 1 pass, 2 pass, 3 pass chiller, and also flooded type and dry type. So this is a more detailed one. So let's see how the name come from. So the shell and tube heat exchanger is how the chiller transfer heat. So we have a shell and also a tube. Inside there's a lot of different small tube. Then the refrigerant come inside this shell and tube, inside the shell first. They go inside the shell and they fill up the shell, then they come out. Then in between there's a lot of tube. So the water will come in the tube, then make a heat exchange with this refrigerant, then come out as a chill water already. So the water come in and they pass through this refrigerant one time, then this is called 1 pass. 1 pass chiller, or they call it the evaporator is 1 pass. Now the type is 1 pass type. So there's 2 pass, there's 3 pass also. So let's see, this one is 2 pass. 2 pass means you pass through 2 times. Then the way they orientate it is a U shape, go in and U-turn. For 3 pass will be like a S shape. So, but typically most chiller is using 2 pass. Is between cost and efficiency is the 2 pass one is most people will like to use 2 pass. And if you see the refrigerant go into the shell and the water go into the tube, this is known as the flooded type. Okay, if you reverse it, right, the refrigerant go into the tube, then the water goes into the shell, is called the dry type. So for large capacity chiller, right, most of them is flooded type. Only the small one is using the dry type. So this is only applied to those chiller that are using shell and tube heat exchanger lah. So this is a real life photo of a small shell and tube heat exchanger. So now let's see how a chiller fit in as a system, right? We call it the chill water system. So how it fits inside the system. So here we have a water cooled chiller. So we know the chiller will, take in the chill water from this, we call it chill water pump. Chill water pump will pump in the chill water into the evaporator of the chiller, right? Then the chiller, of course, the water will come out of the chiller after being cooled by the refrigerant, will come out as a water. The chill water will go into the air handling unit and the fan coil unit, right? So the AHU will circulate indoor air, then that's where you get the cool air, right? So if you see inside AHU coil, this coil is actually different from this normal house air conditioner. Usually we use refrigerant, right? We send refrigerant inside this tube, then we get the cooling. But for AHU that fits inside this one of the chiller system, right, they actually take in chill water. They use cold water. Then the indoor air circulates through, then you produce a cold air. So the working principle is more or less the same, just the medium we use for heat exchange is different. Now we're using chill water. So then we continue, then the chill water come out, is a bit warm already, right? Absorb heat already, then it return back to the chill water, then you continue this cycle. And the chill water goes back to the chiller, we call it the chill water return. Then the one come out is supply. So this is a chill water loop. And one side is cooling, another side we must reject heat, right? So the heat will be rejected through the condenser side. So again, same, the condenser water pump will pump in the condenser water. So this is known as the condenser water supply because we are supplying it to the chiller. Then come out as a return. Return to where? Return to the cooling tower. Water cooled chiller will use cooling tower. Okay, then again the same thing. The water will go back to the pump, then it will cycle as a loop. Then this is the condenser loop. So at the cooling tower there, the cooling tower will use outdoor air for heat rejection. We throw the heat outside for the air. And how cooling tower works is you just spray the water, go down like that. Then all this green color thing is, we call it the infill. Just plastic, to increase the water contact surface area. It's like spray. You make it spray, then it's very easy for the water to cool down. And this cooling tower is cooled by the principle of evaporative cooling, right? So now we have this the entire water-cooled chiller system. Now, basically it just works like that. What if we replace the chiller with air-cooled chiller? Now, let's see what happened. So when you replace with air-cooled chiller, you basically get rid of the entire condenser side, right? You don't need already because the air-cooled chiller itself is already capable of reject heat because it has the heat exchanger, it has the condenser fan, so itself also can reject heat already, just like a normal air conditioner, right? So that's the benefit of this air-cooled chiller. The system becomes much simpler and much smaller. So now let's see between water-cooled chiller and air-cooled chiller, who is better and what is their differences. So for water-cooled chiller, obviously it's more expensive. You can see we need a whole set of equipment for the condenser side, right? But the benefit also, it is quieter because anything with fan will be noisy. So if we are talking about just the chiller, then the chiller will be quieter. Then of course you have to take care of the noise generated by the cooling tower lah. And the chiller itself, the location is quite more flexible than air-cooled chiller. For air-cooled chiller, you need to put at the roof or somewhere open air. Usually if you have a high-rise building, right, usually your location just at the roof. Maybe you have another balcony, something like that, but mostly it's on the roof. For water-cooled chiller, you can put on the ground floor, basement 1 or basement 4, or even level 6 like that if it is a mechanical floor. So it's more flexible. And the best thing about water-cooled chiller is the efficiency, right? It's more expensive, but it is much more efficient than this air-cooled chiller. On the other hand, air-cooled chiller, the good thing about air-cooled chiller is, just now I said, you can add up the capacity. It's sort of like quite flexible on the capacity if you want to upgrade in the future. And another thing is it saves space. We are talking about as a system, because you get rid of the condenser side, so a lot of equipment, cooling tower, pump and the piping, you don't need cater the space for those equipment. But just like I said, you need open air location. It is noisier, and also the most importantly, it is not as efficient as the water cooled chiller. So the last part we want to discuss is why this air cooled chiller is not as efficient as water cooled chiller. Actually, the principle behind is very easy, because water cooled chiller, it relies on cooling tower for heat rejection, and cooling tower works with wet bulb temperature. Then air cooled chiller works with dry bulb temperature, and naturally, right, dry bulb temperature is higher than the wet bulb. So for air conditioning, if you want to do heat rejection, the lower the temperature, the better the performance, right? Because we can reject more heat, that means we get more capacity. So because the wet bulb temperature is naturally lower than dry bulb, so we can take advantage of that.